All right, let's update the Chapter 9 notes. So locating the important points and features of a parabola. All right, we are going to go after 3 at this time. Okay, so 1 is going to be the axis of symmetry. And we're going to go after the vertex and the y-intercept. Okay. So, axis of symmetry comes with a formula. Okay, so on the axis of symmetry, the formula is always x equals the opposite of b over 2 times a. So the opposite part is always part of it. It's always going to have this fraction structure, and the 2 is always going to be a 2. Okay? So we should probably try to throw an example in here. Let's do an example problem so that we can talk about what we mean by these A's and B's as well. So let's take a look at y equals negative 3x squared plus x, and we'll go with a minus 4. Okay. So, that made my life difficult, but that's all right. So, what we're looking at here then is the first part here, the A's, B's, and C's. This follows a pattern of the standard form of a quadratic equation, which is y equals ax squared plus bx plus c. The a, b, and c are just numbers. They're the coefficients of these things. The a is always the coefficient of the quadratic term, regardless of what order these things might get written in. If it's not written in standard form, we still need to view it as standard form. So in this case, the a is a, let me go ahead and do this. The a in this example is a negative 3. The b in this example is a 1. It's there because that's lazy mathematician shortcut. And the c is a negative 4. And so my computation would be x equals the opposite of b, which is 1, over 2 times negative 3. Which is two negatives in there, going to make a positive. That's going to be 1 over 6. Okay. Oftentimes it's not a fraction, but if it is a fraction, we deal with it as a fraction because fractions are numbers too. All right. So that is how we find, and let me write that final form. What we're looking for in this example is x equals 1/6. Okay, if we look back on our notes, axis of symmetry was this vertical line that went through the vertex. And so at 1/6, it'd be a little hard to locate on this one. It's going to be real close to the x-axis. Our vertex would be located on a vertical line that goes through there, which is exactly what we need to know in calculating then where the y-coordinate of the vertex is, because we just figured out that the x-coordinate of the vertex is 1/6. Okay. So our vertex is always going to be located at that x value, that minus b over 2a. And then we're going to plug that minus b over 2a into the function. So I'm going to represent that as an f of minus b over 2a. All right, so in my example then, I'm going to replace all my x's. The y value that I'm looking for is, I've got a negative 3. I'm going to leave parentheses where all my x's were. And I'm going to replace those x's with the minus b over 2a, which in this case was a 1/6. And so that's y equals negative 3/6, which is negative 1/2. Plus 1/6 minus 4, 1/6. I'm going to rewrite my negative 1/2 so that I can talk to this as a negative 3 over 6. That's the same thing. I should have just kind of left it there. Plus 1 over 6 minus 24 divided by 6 makes a 4. So this is a negative 3 plus 1. I want to make sure something feels a little bit off here. Just a second. All right, I knew something seemed wrong. I forgot to square it like it was the x squared here. So this is going to be a negative 3 over 36 plus 1 over 6 minus 4. I can reduce this fraction a little bit. Those are both divisible by 3, so this is a negative 1/12 plus 2/12 minus, I'm going to make that a 12, 48 divided by 12 is 4. So I've got 1/12 minus 48/12 feels like a negative 47/12. So my point here in the example of the vertex is at 1/6 comma negative 47/12. Okay. So that's how I find the vertex. I'm trying to color code these here. And so finally, to do my y-intercept, I'm going to do the y-intercept is just going to be located at the point 0, comma c. Okay. So 0, comma c, in this case my c I identified was a negative 4, and so the y-intercept on this one is at 0, comma negative 4. Now, that's going to allow me some information potentially in finding another point that is on that graph, because if I knew that at 1/6 I've got my axis of symmetry and the y-intercept is at 0, comma negative 4, then by symmetry to the right of the y-intercept, since this is to the left of the axis of symmetry, to the right of the axis of symmetry the same amount, so this gap is 1/6, so that would be another 1/6, 2/6 is 1/3, that would put this point at 1/3 comma negative 4. And I'd be able to say that that point is also on this graph. So I know where the vertex is. It's going to be way down here somewhere, negative 47/12. So, well, I guess that's only at negative 3, just shy of negative 4. So that vertex is going to drop in somewhere like that, and my parabola is going to be spread out fairly, or it's going to come down like this. About as good as I can get it in there. Okay, so that's for standard B, how to use an equation of a parabola to find the axis of symmetry, the vertex, and the y-intercept. We will eventually also be working on finding the x-intercepts, but that is a little bit more challenging. This we can get our notes updated here anyway for standard B.